Hello everyone, it's my honor to present our work EntAugment here, which is an entropy-driven adaptive data augmentation framework for image classification. The prevalent data augmentation methods adhere to a statically invariant strategy, which is uniformly applied to all training samples. And these methods typically employ randomly sampled parameters to adjust the strength of augmentations. As a result, the variability in the augmented data is stochastic and non-adaptive to training samples and target model training status. For different datasets and models, the augmentation parameters have to be manually customized or searched prior to task model training. And the uncontrolled variations in the augmented data increase the overfitting and underfitting risks of our target model. So it's beneficial to dynamically customize the extent of the manipulation for each training sample. And this customization should take into account of both the sample's inherent difficulty and the model's training status. This adaptive DV framework also aligns with the principles of curriculum learning. So we propose our methodology EntAugment. Given a classification model f theta and an input sample x, we use g of x to donate the output of the softmax function. Based on the information entropy of the softmax output, we can derive the magnitude of DA manipulations as this equation. The magnitude scales to the range of between 0 and 1 and exhibits an inverse proportional relationship with the entropy measures. Meanwhile, the magnitudes remain dynamic and evolve continuously throughout the training progression, and which enables adaptive augmentation. Since the model's confidence scores in data classification may slowly increase and stabilize at a moderate level, which can be seen in this figure below. So the magnitudes derived by the vanilla curve entropy loss could remain constantly low throughout most training epochs. So we introduce another entropy regularization loss, which is defined in this equation. And we have some theoretical analysis. The proposition 1 reveals the advantageous effect of end loss in mitigating the dissimilarity between the model distribution and the dataset distribution. In conclusion, the end loss facilitates models to better fit the inherent distribution of the dataset, thereby achieving enhanced generalization. We also conduct extensive experiments on various benchmark classification datasets to evaluate our method's effectiveness. For the results on CIFAR 10 and 100 datasets, we demonstrate that our method achieves the best results on these benchmark datasets. And we also evaluate our method on large-scale long-tailed ImageNet-LT datasets and show that our method can generalize well on long-tailed datasets. To assess the efficiency of our method, we present the trade-off between the effectiveness and efficiency. And in this figure below, we show that our method achieves the best trade-off in effectiveness and efficiency. making our method the best performing one with very high efficiency. Okay, we can have some conclusion here. We propose EntAugment, a novel tuning-free and adaptive DA framework, which can dynamically adjust the magnitudes of DA operations based on sample difficulty and the target model training progression. We also pinpoint that the sample difficulty is not static but varies through model training. We also introduce EntLoss, which is an entropy regularization loss term for classification model training, which is accompanied by theoretical foundations. Finally, our proposed work can be directly applied without any Alex-ray models, and extensive experiments also demonstrate that our method achieves the best performance.